Hello everyone, it's Kevin from kjdElectronics, and welcome back to another one-stop programming video for absolute beginners on Python. If you recall, in the last video we went over for loops, lists, and dictionaries, and I tried to tie up some loose ends because I said that in this video we would move on to the really fun stuff. Well, good news, it's time for that really fun stuff. We are going to start exploring the world of object-oriented programming and what a class is in Python. And now in order to do that, I've prepared a brief, I promise, PowerPoint presentation just to kind of orient us into that environment. Alright, so this is our 9th tutorial, so I figured, one before 10 we should start to get into some really cool stuff so that in the 10th video we can be, spot on, awesome times. So what are we going to go over in this PowerPoint? First, we're going to cover vocabulary so we can orient ourselves to what all the words I'm going to be using throughout this video are so you can understand the context. Then we're going to go over a high-level overview of what a class is in Python with a great diagram that I made. We're going to review our first class. It's going to be a dog class, woof woof. And then I'm going to get on with it. And we're going to go over what we're actually going to build in this video, which is the fun stuff. Alright, so what is a class in Python? A class is a programming construct to model a functional component or behavior. Just remember that in the back of your head. That's the Webster Dictionary definition. Probably doesn't mean much, but hopefully by the end of this, you'll kind of understand more about what that actually means. An object is an instance of a class. What's an instance, you might ask? An instance is an independent version of a class created at a specific memory address. Wow, this all sounds complicated. Trust me, it's really not. Let's take a look at this diagram. So on the far left, we have a class in that green box, the dog class. And the class is made up of different properties and different functions because it's a functional component and models behavior. And in order to do that, it needs to have properties or variables and methods, functions to do things. So in our dog class, I've given our dog a name, and that's going to be a string type. I've given our dog an age, and that's going to be an integer. And I've given our dog two behaviors. It can bark, which is a function that takes no arguments, and it can run, which is a function that takes one argument that's an integer named distance. Once we define our class, which we'll learn how to do in the next slide, we need to instantiate our class in order to get an object, which is an instance of our class. Now, referring back up to those vocabulary terms, you can kind of glean what I mean there. So in order to instantiate, we need to call the constructor of the class. And we'll learn what the constructor is, but for now know it's a special function that creates an instance of the class, an object from the class. After we call the constructor, and we can call the constructor as many times as we want to create different instances of the class. And every instance of the class will behave the same way. It will have the same properties and the same methods. So every dog that we create will have a name and an age, and every dog that we create will be able to bark and run. So we look over to the lightish green, we see that the first dog that I created, I named Spot, and it's a 1-year-old puppy. The second dog I created is named Buddy and is 6 years old, and the third dog I created is named Lucy and is 5 years old. And now all three of those instances can bark and run. Now, just to provide a little bit more insight as to what the whole created at a specific memory address thing means, it's not something you need to worry about, but I do want to illustrate it by pointing out the memory address on the far right. Every object that you create lives at a specific spot in your computer's memory, or RAM, random access memory. And every spot in memory has a specific address, which is that really weird looking, number, which is actually a hexadecimal number that represents the binary address of where that memory is in your computer. So given that address, imagine, driving up and finding Spot, just living in your RAM somewhere. That's kind of what it's like. Spot lives at 0x345 or 34FA050. That's not something you need to worry about when you're using an object or on a regular basis, but it's good to know that that's what's actually happening on the back end. Every time you create an object, it requires some amount of memory based on what's in there, and it gets saved in memory. All right, so let's keep going here. Pulled out our dog class, and I've added another method here. And I've also created the code on the right. Let's focus on the left to start with. So we've got our name, our age, a string and an integer, our bark method, and our run method that takes an integer that's distance, which is how far that dog is going to run. There's also this special __init__ that takes 3 arguments: self, name, and age. Now that init function is a special function in Python that is the constructor. That is how you define the constructor for a class. Now remember, the constructor is what instantiates and creates our object from the class. It's how we create a Spot, a Lucy, and a Buddy, by calling that constructor. Now looking over to the right, we can actually see how we define a class. Now in the next slide, we're going to go over a little bit more of what all these different components mean, but I just want to point to the constructor to show that it takes 3 arguments actually, but really only 2. Note that every argument or every method takes self, and that's just something that Python requires, but it really takes name and age. And we set name and age in our class because our constructor is responsible for building our object. All right, so let's take a look on the next slide and get more deep down into what this code actually means. So I'm going to start with the orange arrow, the constructor. That is our constructor. That's what we call to instantiate a dog class. If I want to make a Lucy, I call the constructor and I pass in 2 arguments. I say a string Lucy, comma, age 5. And then the properties will be set, that blue arrow off to the right. We set the properties by saying self dot whatever we want to call the property equals whatever we want to set that property to. It's just common practice that you use the same names, but you don't have to. So I could have called input name and said self.name equals input name. All methods require self, and that's that red arrow off to the left. Now, if we look at the question down at the bottom, what's the deal with self being everywhere? Well, in Python, self represents the current instance of the object we are working with. It's automatically passed in as the first argument in every class, including the constructor. So see how it's kind of in that lightish purple color? That's PyCharm telling you it's special. It's not a regular argument. It will get passed in automatically by Python, and you don't have to worry about it as long as it's there. Self is needed to access class properties, in this case name and age, and our methods bark and walk within the same instance of the class. So self.name references the name of the current dog instance. Now when you go to define a new method, PyCharm will automatically help you out with this and add self when you create a new method. And we'll demonstrate that when we actually get to code. So now going back up to the code, in the bottom left, you see the red method arrow pointing to def walk self, comma, distance. Now distance is a parameter just like any other function. And I will end up calling this just like any other function. And it really just is any other normal function at this point. And I'm just going to say print, I just walked the distance of blank, insert whatever the argument was passed in as a string. So we go up, we'll see the green arrow that says access instance variable. Now, since we pass in self to every function, we can access instance variables like name and age within those functions. And without self, you wouldn't be able to do that, so it would be kind of useless. So that's why self needs to be there. So we say print Wolf, my name is self.name. So this would print Lucy, Buddy, Spot. So now that we have this kind of overview of what a class is, we're going to figure out what we're actually going to do in this video and get on with it. First, we're going to define a game class to represent our rock, paper, scissors game. Second, we're going to learn how to call the game's constructor to instantiate an instance of the game class, thereby creating a game object. Now, if that's still a little fuzzy, I recommend you hop back to the first slide where you see that diagram and we call the constructor 3 times to create 3 separate instances of our dog class. Now, third, we're going to learn how to call a method belonging to an instance of the class. Remember that an instance of a class is an object from that vocab slide. Now, in this video, we're going to use the source code from the stock rock, paper, scissors game that Zibzo created. We will focus on improving the logic and structure of that code in a future video. For now, we're just going to focus on getting our class. Now, this presentation will be available for download as a PDF. See the link in the description. And I'm really looking for feedback on the most effective way to communicate these complex topics that require some background knowledge. All right, so let's get on with it. Back in PyCharm, I'm going to create a new file that we're going to work with in this video. So I'm going to right-click on Hello World, do New, Python file. I'm going to call it RPS for rock, paper, scissors, and I'm going to create it. Now, I already have open in Chrome the rock, paper, scissors thread from the forums that I'll link in the description. So I'm just going to copy this code and paste it back into PyCharm. So the first thing that we're going to do is define our game class. Now I'm going to show the dog class that we made up on the screen now, and we're going to model our game class after that same syntax. So we're going to go up to the top of the screen, and I'm actually going to switch into this cool presentation mode that I found that makes the code really big and full screen so it's easier to read. I'm going to do class game : I'm going to press enter, and now I'm going to def __, and as soon as I type the 2 underscores, PyCharm's going to help us out with this predefined function that is the constructor, and that's exactly what we want. So I'm going to double click on that, and it's going to complete the rest of it. Our game class is going to require 1 parameter in the constructor, and that's new player name. All right, so now this is effectively just like any other function, except we are going to initialize all of the properties and variables that we need in our game. So if we look down here at the main function from the file we just imported, we see that we need a couple variables. We need a bot hand and a user hand. Now, we're also going to create a winner variable that will hold basically this text, you win, you lose, you tie, or invalid input, that we're going to use to store in the class. So to do that, just like our dog class, I'm going to say self.playerName equals new player name. Now remember, these don't have to be the same. It's just common practice that they are, but I've illustrated a case where they are not. Then we're going to say self.playerHand equals NA. And we're just going to initialize it to not available. And we're going to do the same for bot hand equals NA. And we're going to do the same for our winner variable, which is going to be NA. Or actually, let's make that no winner yet. All right, and the last thing that we're going to do is we're going to print new instance of game class for self dot, And now that I go to type self, you'll see that it auto-completes as I start typing, as soon as I hit dot, all of the variables that are within this class. So PyCharm knows that these are now properties of the class because we define them up here in the constructor. And now it knows that I can use them. So I can hit dot and see player name. So we're going to say new instance of game class for whatever the player name was. And this will let us visually see when this special constructor function is run. All right, so the next thing we're going to do is we're going to define a behavior for our game class. We are going to define a run game function. Now, note what happens as soon as I type the open parenthesis. It automatically puts in self and puts the cursor in a spot where we could type additional arguments. Now that's the part where I said that PyCharm is going to be really helpful here and automatically put self into every method that we define for our class. What are we going to have in the run game? I'm just going to go down here and I'm going to copy and paste everything that we have, basically all of this game logic that we have down here. And we do a Control X and a Control V. And I'm going to delete everything except this print invalid input, try again. All right, so now that we have this logic in our run game function, there's all kinds of errors everywhere because user hand and bot hand aren't defined. Now you might say, okay, I see that user hand isn't defined, but we totally made bot hand up here. Remember, in order to access our instance of the class, we always need to use self dot. If we're not calling self dot, we're not going to be able to access the current instance of the game class that we have. So we need to replace every appearance of user hand with self dot player hand. So I'm going to copy this. I'm going to go through real fast and do that. That was quick. I'm going to do the same thing for bot hand. I'm going to replace every appearance of bot hand with self.bot hand. Wonderful. Now, the last thing I want to change in this run game function is I want to replace all of these print statements by setting our self.winner to be whatever the result of the game is. So to do that, I'm just going to replace all of these with self.winner equals, and then whatever string is inside the print statement. All right, that was quick. Now, I did that for every single one, including the else, which is invalid input, try again. All right, so this is our game class. It has some variables, and then it has a behavior, run game. Now note, run game doesn't take any other arguments except for self, which is really a hidden argument, and we'll see that we don't actually have to pass in anything when we call this run game function. But now we're going to learn how to instantiate an instance of our game class and create a game object by calling the constructor. So we're going to scroll down to the main function, and I'm just going to delete everything else that's there. And now I'm going to create an instance of the game class. I'm going to do that by saying my game equals, I'm going to do game, and then an open close parentheses. And then when I do that, you'll see that it came up briefly and said new player name, because it recognized that this is a required argument for the constructor. So I'm going to type a string Kevin. So basically all we do to create an instance of a class is we need to know the name of the class. In this case, it's game. Note, classes are with an uppercase first letter, so it's uppercase G, game. So we call game, and then we call what our constructor kind of implicitly, this init function is called internally and automatically when we use this syntax. The name of the class, and then an open parenthesis, and we pass in the argument of new player name. And like I said, self is going to be passed in automatically by Python. We don't need to worry about it. we just pass in any argument to the right of self. So we pass in Kevin, so we're going to create an instance of my game, and that will set these variables, and we'll print out new instance of game class for Kevin when we instantiate the class with this line. So we're going to go on to the next line, and now we're just going to print out all of the variables that we have in the class. So we're going to do print my game dot player name. Print my game dot player hand. Print my game dot, and notice I'm using the dot on the instance, the object my game, just like I was using self up in run game above. Anytime we want to access a variable or a method within a object, we use dot. And I'm also using autocomplete here, that PyCharm comes up and is telling me and suggesting what I should type. So now I'm going to do bot hand, so I'm just going to use the arrow key to go down and tab to bot hand. I'm going to do print my game dot winner. All right, so that will print or instantiate and print everything that we have in our class. So let's go ahead and exit our presentation mode here. And let's run this code. So since this is a new file, I'm going to need to edit the run configuration. So I'm going to go to run, edit configurations, and then I'm just going to make sure that our RPS file, our rps.py is selected. In this case, it already was. If it wasn't, I would click the browse button and click on it. Okay, cool. So now I can go up to run test, and it didn't do anything. And this is actually a great example because I get this comment a lot in YouTube. It just process finished with exit code 0. But Kevin, I just wrote all this code that should have created an instance of my game and then printed out all this stuff. What did I forget to do? I forgot to call our main function. Oops. So now if I run it again, we'll see that it actually runs new instance of game class for Kevin. So this is our constructor running. Then Kevin, NA, and no winner yet. Perfect, that's exactly what we expected. But now, let's run it and try to get a winner. So we'll go down here. And in order to get a winner, I need to set our variables. So I need to do my game dot player hand equal, and if we look up here, we see that player hand has to be a string of rock, paper, scissors. So we're just going to do paper, and my game dot bot hand. If we look up here, we see that it has to be an integer. So in this case, we're going to do 1, which is scissors. So we're going to, in the next video, we're going to go through and improve this class to make it easier to understand, easier to read, more efficient, and more powerful. But for now, we're just going to go with this. So we're setting our player to paper and our bot to scissors. And now we're going to do my game dot run game. So this is just like any other function, except instead of just calling a function like run calculator, it's my game dot run game, because we want to run the run game function of our object my game, of which this is the instance we're working with. Now this will run this function and it will set the winner variable. So then all we need to do is print out the winner by saying my game dot winner. Now in this case, we expect it to be you lose, since scissors, the bot, cuts paper. Now before we run this again, I also want to illustrate how flexible this is by creating another game instance. I'm going to call it other game. I'm going to say equals game. We're going to call the constructor. And the new player name is going to be Zibzo. The user who submitted this code. And then we're going to do other game dot run game, which we expect to be invalid input, since in our constructor we set just player hand and bot hand to NA, which isn't going to be valid. And then we're going to do print other game dot winner. So we can just kind of get an understanding of how flexible this is. We can have a completely separate independent game, and that's all the code we need. That's it. All right. So let's exit presentation mode, and let's run this. All right, new instance of game class for Kevin. Kevin, NA, which is exactly what we expect because we're printing the player name, player hand, bot hand, and then no winner yet. Then we set the player hand to paper, the bot hand to scissors. We run the game, which sets our winner. We unfortunately lost. Then we create another instance of game. It says new instance of game for Zibzo. We run the other game, and then we print the winner, which in this case is invalid input, try again. So we would have to reset the bot hand and player hand and then run the game again. All right, so that's all I wanted to cover in this video. In the next video, we're going to cover, how we can make this game class more efficient and better. Please remember to comment with your feedback on how you like the format of this video versus the format of the last video where I had all the code pre-written. I've also created a heavily commented version of this that I will post so you guys can go over it and get a read line by line version. The links for everything will be in the description. Please remember to like, comment, and subscribe. I'm Kevin from kjdElectronics, and I'll see you in the next video.